All right, so we're going to prove the midline theorem, which states that if a line is drawn from the midpoint of one side of a triangle parallel to the second side, then it bisects the third side. So aka, if AB is parallel to DE and E is the midpoint of BC, then DE must bisect AC. So let's go ahead and start this proof. Okay, so we know that AB is parallel to DE. So this implies, by the corresponding angle postulate, right, that this angle is congruent to this angle, and this angle is congruent to this angle. So we have that this implies that angle ABC is congruent to angle, so ABC is congruent to DEC, right? Angle DEC. And we have angle BAC is congruent to angle EDC, right? BAC, EDC. So if we have two angles congruent to each other, two corresponding angles congruent to each other in two triangles, this means by the angle similarity postulate, right, that triangle ABC is similar to triangle, so ABC is similar to triangle DEC. So if they're similar, this implies, right? This implies that BC over EC, so BC over EC, right? We want BC over EC is equal to AC over DC. So AC over DC, right? AC over DC. All right. So, and we know E is the midpoint of BC, right? Since E is the midpoint of BC, this implies that BC, right? BC is equal to 2 ECs, right? Because since BE is congruent to EC, that means BC is 2 ECs, right? So this is equal to 2 EC. All right. So now I have this right here. Instead of writing BC, so this implies that 2 EC, since BC is the same as 2 EC, over EC is equal to AC over DC. So this means EC over EC is 1. So this implies that 2 is equal to AC over DC, which of course, I can multiply both sides of this by DC. I get 2 DC is equal to AC. So if 2 DCs equal AC, that means AD is congruent to DC, so that means D is the midpoint of, or yeah, D is the midpoint of AC, right? So this implies D is the midpoint of AC. And if D is the midpoint of AC, that means this line DE bisects AC. So this implies that DE bisects AC, right? And that's exactly what we wanted to show. We wanted to show that DE bisects AC, given that AB is parallel to DE and E is the midpoint of BC. So that's our proof.